there are lessons to be learned all across the board. Do things that prevent the direct flow of water either into rivers or into sewage systems. Plant vegetation where you can to block the flow of water and suck up the nutrients. And then where you do have sewage, install modern sewage treatment systems that can remove nitrogen. But all over the world, where we implement these strategies, the water is getting cleaner, not dirtier. The problem is where we aren't implementing those strategies.
I'm Dale Walkinen, and this is Facing Future. Today, I'm delighted to welcome two guests to our program. Stephen Porter is an Associate Provost for Sustainability and Acacia Professor of Ecology, Organismal and Environmental Biology, and Environment and Society at Brown University. He's also co-founder of the Sustainability Science radio show and podcast, Possibly. Lenny Meyerson is an environmental engineer and former Deputy Commissioner of Environmental Health in Westchester County. Welcome to you both.
Hey, Dale. Thanks for having us.
Good to have you here. Stephen's book, How 5 Elements Changed Earth's Past and Will Shape Our Future, starts in the deep geological past and probes how previous organisms have changed the world by evolving new ways to gather essential elements from the environment. Humans are now changing the global environment in basically the same way, but at a much more rapid pace than any evolutionary change in the past. The industrial fixation of nitrogen, as well as phosphorus entering the ocean, has so disrupted global biogeological chemical flows that they are well beyond safe boundaries for planetary health, according to the Stockholm Resilience Center. The Haber-Bosch process, which synthesizes nitrogen into ammonia, NH4, has increased crop yields so dramatically that human population has exploded beyond sustainable levels. Added to this, runoff of nitrogen from croplands from intensive animal farming pollutes waterways, leading to algae and dead zones. Nitrous oxide, a greenhouse gas 300 times more potent than CO2, depletes the ozone layer. As the climate warms, heavier rain is producing floods that sewer systems and other infrastructure were not designed to handle, further increasing nitrogen runoff and algae blooms. A critical element has become a critical problem. Stephen, what are the essential elements and why are they so central for everything on Earth?
These elements are essential because they underpin all living organisms on Earth. If you ground us up and analyzed our chemistry, you would find that we are all, from the smallest bacteria to the human to the blue whales, we are all hydrogen, oxygen, carbon, nitrogen, and phosphorus. And we're going to focus on those last two for this conversation. But I actually want to start with carbon for a contrast. Many of your viewers will be familiar with the problem of climate change, of course, and that's a problem essentially of humans finding chemical energy stored as carbon and burning it and releasing that CO2 to the atmosphere. And this is what you and I do when we eat plants or we eat other things. We break down chemical bonds that are carbon bonds and we burn it in the presence of oxygen and release that CO2. Unfortunately, or fortunately for humans, we figured out how to get enough energy not just to fuel our bodies with carbon, but to fuel our whole society. So all the electrons that are facilitating this conversation, or almost all, are coming from burning of fossil fuels, and that's what's causing climate change. The beautiful thing about carbon, at least for fueling our industrial society, is that it's totally replaceable. You can swap out solar panels and windmills and batteries and replace the fossil fuels that we're using to provide energy to our society. Just as a good example, since you started with a lot of bad news in your introduction, fossil gas use in California for generating electricity is down 40% over 2 years ago. And that's because solar and wind and batteries have come online to such an extent that we're replacing those fossil fuels. So carbon is a fixable problem because the energy we get from it is replaceable. Now let's turn to those other two you want to spend time talking about today, nitrogen and phosphorus. Those are elements that are the essential building blocks of the biological molecules, just like carbon, that we're made up of, but they're not replaceable. We can't substitute solar energy for nitrogen. We can substitute solar energy for oil and gas. In order to grow the crops we need to fertilize our farm fields with nitrogen and phosphorus in order to make them grow. But when they escape to the environment, as you mentioned, they cause all sorts of environmental problems. And so the trick with them is to find a way to manage them, to keep them where we want them, to use them for what we need them for, without disrupting the rest of the planet by letting them escape. And that's a different challenge in terms of sustainability than the global warming problem, which is essentially how do we swap out fossil fuels for other sources of energy that don't produce CO2.
Well, Lenny is works with the water systems and runoff. What's happening, Lenny, in terms of nitrogen phosphorus runoff in your experience?
Nitrogen and phosphorus are part of an ecosystem balance that humans, especially because our numbers are so much greater than any other species in terms of growing to much greater extent than we could without the technology that allowed it, we have thrown all the balances off. We tend to congregate in urban areas. There's too many of us in one place. And when that happens, you have an imbalance where you pollute water bodies, you pollute the air. In terms of what's going on in my particular field, which has to do with water quality, there's a few very important factors. The first is, as we develop, we destroy the natural buffers that allow the balance of nitrogen and phosphorus to stay in stasis. We want to pave over where there were wetlands, we fill them in. Nature has natural ways of monitoring the phosphorus and the nitrogen. Waste that humans produce contains nitrogen and phosphorus. Even when you have sewage treatment plants, the sewage treatment plants control how much oxygen demand is being used up in the water bodies as it discharges. But nitrogen and phosphorus are harder to break down than the carbon, which is broken down first in the processes of sewage treatment plants. So without advanced treatment, the water bodies find a greater concentration of nitrogen and phosphorus than they can handle. When that happens, you affect the biosystem, the natural microorganisms that are part of the biodiversity in the ecosystem are thrown out of balance, and the biology of the ecosystem is affected. You end up having algae blooms that use up the oxygen as the algae die off, and you end up having to find ways using technology to control that. And the more times you do it, the more times you need to have more technology to improve that situation. We have created
So do we
a
need a
problem.
more advanced? Do we need to update the infrastructure of sewage systems and water treatment around the country? Where are we with that kind of technology? Is that possible as we have these immense rainstorms that we're seeing, where beaches are closed and raw sewage is getting into neighborhoods?
Can I jump
Where are
in?
we going with that?
Can I jump in for 1 sec, or maybe for
Absolutely.
seconds? So I think it might be helpful for our listeners to sort of contrast the two ecosystems that Lenny was talking about, the sort of urban ecosystem where we have the sewage treatment need and sort of a quote unquote natural ecosystem, because I think that's sort of conceptually where we need to start in order to understand the scope of the problem. So imagine you're in a forest or a grassland or some natural ecosystem, and you're specifically interested in how nitrogen and phosphorus are being used in that system. So in those systems, typically, the amount of nitrogen and phosphorus coming in from the outside is very small. The amount that's leaving the system is very small. And the amount that's cycled within the system is really, really big. So plants die, they decompose, that nitrogen and phosphorus becomes available for other plants or other organisms, and that's taken up and it's cycled. And so typically over 90% or 95% of the elements, nitrogen and phosphorus in that system, are moving in the system, not coming in and not going out. If you look at what humans now do, we take huge amounts of land, about 15% of the Earth's surface is used for farming, and we dump enormous amounts of nitrogen and phosphorus on those lands in order to make our crops grow. We then ship those crops to wherever we are, eat them, pee and poop them out, and then have to deal with that as it goes into waterways downstream from our sewage systems, right? So instead of having very few inputs, very few outputs, and lots of internal cycling, we have a system where we have huge inputs at the farm, transport to the city, and then huge outputs going out, right? And so the challenge is, how do we deal with that in a way that doesn't pollute our waterways? Now, you're absolutely right that we have a big problem with these nutrients flowing into waterways. But for example, where I live in Rhode Island, Narragansett Bay is way cleaner than it was 40 years ago because we've made major advances in sewage treatment. And that's true in a lot of places in the world. Dale, you mentioned that climate change is providing a challenge to that with more intense storms. That's certainly true. But it is a manageable problem. We're just using sewage infrastructure that was built 100 plus years ago because it's very expensive to redo. But particularly for nitrogen, urban centers actually provide a pretty easy place to get the nitrogen out of the water because it's concentrated. In contrast, if you look at nitrogen fertilizer draining out of the Midwest, you're dumping all this nitrogen on a huge area. It's much harder to then control it, right? Whereas if you're taking crops and shipping them to cities, at least you have people in one place. You can build one sewage treatment plant. I mean, not one literally, but like it's more containable. So I just think it's important to conceptualize. We have this problem of nitrogen and phosphorus runoff from farm fields during storms, very, very hard to control. And then we have another sort of urban sewage challenge, which actually in a lot of places we're making huge progress on. If you go to Paris now, you can swim in the Seine for the first time in a hundred years, right? That's because we've made progress on pulling nitrogen and phosphorus back out of water before it goes into the. So we haven't made progress everywhere. Climate change is definitely a challenge, but doable, right? It's actually, in my opinion, harder to do it upstream at the farm level just because of the land area that we're using and that we're using fertilizer.
Good point, Stephen. That's just to segue in with what you're saying. You mentioned how old the infrastructure is. Sewers were constructed, most of them started to be constructed at the beginning of the 20th century. A lot of those sewers were never maintained, and a lot of them were made out of clay and are cracked. And it creates a huge problem because municipality is expensive to go in and fix those. A good real life example of how we can improve the situation is the Long Island Sound, which I know that's something near and dear to you, Dale, because you grew up in Long Island. You had wetlands that you knew when you were a girl, and you saw them filled in and paved over and constructions happening there. The EPA has a program under the Clean Water Act where they evaluate the key pollutant that's causing a problem. Anoxia, there's a lack of oxygen in the Long Island Sound that affects the biosystem. And that is the limiting factor. That is what makes the Long Island Sound more polluted more than any other pollutant. It doesn't mean other pollutants aren't a problem, but they analyzed if we reduce the nitrogen 58% below the current levels, then we could reverse the trend and it could start to recover. And that has happened. This program, which is a partnership, a lot of it has to do with environmental activists who were involved as a coalition together with local government and the federal government. And it's an example of how working together, how you can make real improvements. The best solution was, because in sewage treatment plants, you bring all that pollution all in one place at once, is you have tertiary treatment to do nitrification and remove the nitrogen with advanced technology. That is a huge part, but it's also has to do with runoff and how do you control that? Things like vegetated swales, not letting runoff just go straight into the Long Island Sound all at once, but to create things like constructed wetlands, which replace the ones that have been destroyed. So that combination has improved the Long Island Sound over time. And the other point that Stephen was saying, how yes, in rural areas, it's really land management. That's a whole other way of viewing the technologies that have to be used. Best management practices, farming according to more earth-friendly methods.
Can I just jump in there? Because actually, I think Lenny brought up a couple of really great points that I think are really important to unify the conversation. So the first thing is that vegetation is really good at taking up nitrogen and phosphorus. And so if you've destroyed your wetlands to build right up to the coast, or you've destroyed your riparian areas, the zones along rivers, right, that are vegetated zones along rivers, then you get nutrients pouring directly into those water bodies. Whereas if you restore vegetation in those places, they act as natural buffers and they are a natural pollutant removal system. And I think that everywhere, from farms to cities, people are beginning to see that the really critical role that vegetation can play. And by the way, Lenny also mentioned runoff. I think we have a huge problem with the amount of, for example, parking lots that we require everywhere, because those are impermeable surfaces that just shunt everything directly to the sewage system, and the sewage system can't handle it. It wasn't built for that, right? And so this is a major problem. I just want to also highlight that although I pointed out that farms are a big problem, you can actually do the same thing on farms. You can plant strips of vegetation within the farm, perpendicular to the direction that water flows, and catch a huge amount of the nutrient pollution. And encourage people who are interested in this to Google the Prairie Strips project in Iowa, where they've reduced nitrogen and phosphorus runoff from corn and soybean fields by over 90% simply by planting 10% of the landscape in native prairie, little strips that go perpendicular to the direction of water flow. So there are sort of lessons to be learned all across the board. Do things that prevent the direct flow of water either into rivers or into sewage systems by allowing it to percolate into the soil. Plant vegetation where you can to block the flow of water and suck up the nutrients. And then where you do have sewage, install modern sewage treatment systems that can remove nitrogen. And we're very effective at that. And so, Lenny and I gave you two examples, Narragansett Bay, where I live, Long Island Sound, but all over the world, where we implement these strategies, the water is getting cleaner, not dirtier. The problem is where we aren't implementing those strategies. So It's nice to, we don't have 100% of the answers, but we could do better. Lenny mentioned also that it's very expensive. And this is where the rubber hits the road. It's what people are willing to pay for, right? If we're willing to pay for modern sewage infrastructure, we'll get cleaner water. Providence just built a huge sort of holding tank tunnel for Providence, Rhode Island, where I live, for their overflow, for their stormwater overflow, so that instead of discharging raw sewage into Narragansett Bay, it goes into this essentially giant tank and then can be fed into the sewage treatment plant at a rate that the sewage treatment plant can handle it. And as a result, the water's way cleaner. So It's doable, it's just expensive.
One thing that I wanted to mention is when the Clean Water Act was passed in 1972, there was a very significant item that was put into the law, which allows citizens to sue if they feel that the Clean Water Act is not providing the necessary protection. An example of how this has been beneficial is the organization Save the Sound sued Westchester County. And that has led to something that I'm working on right now, which is forcing municipalities that discharge into the Long Island Sound to go into their infrastructure and repair it. Because, as I said, it's over a century old in many places. And when you have two basic types of pipes underground, you have sanitary sewers that carry wastewater. Then you have storm sewers. Very often they're next to each other. You have leakage when you have what they call inflow and infiltration, when rainwater and groundwater gets into the sanitary sewer pipes. Those pipes that were designed to carry only so much flow, all of a sudden they're inundated. What happens is you get surcharges, you get manholes that pop open, you get backups, it gets into people's homes, it goes into the streets, it ends up flowing into the Long Island Sound, which defeats all of what we're trying to do. It gets that sewage, which is filled with nitrogen, into the Sound. So there's technologies now where you can go in without having to rip up the street and line sewers. You put a resin in there and it creates like a light new pipe. So we're investigating with cameras and pipes and lining those sewers and getting the sewers back into the original condition, municipality by municipality, and seeing major improvements. And thanks to the Clean Water Act and the citizen lawsuit.
And I would say also, just to highlight, and I totally agree with everything Lenny just said, Like there was a similar lawsuit recently in Iowa where a city sued the farmland stream and said, we can't use our water because of all the nutrients flowing off your farms upstream from us. And
Mhm.
different municipalities in different states have come to different conclusions about whose fault it is under the Clean Water Act and so forth. But this is an active area because on the one hand, well, I should be able to do with my farm what I want. On the other hand, well, but I'm downstream from you and I can't drink the water or use the water. This is very similar to the fights that happen about environmental questions all over, right? Where does the liberty to do what you want run up against the impact you're having on someone else downwind or downstream? These things are being litigated and thought about. I do want to come back to the idea, though, as Lenny said, like there's a lot of this stuff that we can fix. And, I grew up in New York City. If I had fallen into the Hudson in 1975 when I was very little, my parents probably would have washed me for 6 months before they let me back out into society. But, now people kayak around there and swim just north of the city. And the Clean Water Act and the Clean Air Act that Lenny has mentioned both, I think, but whatever, those are two of the most successful and, by the way, cost-effective pieces of legislation ever passed in the United States, especially the Clean Air Act in terms of human health, but the Clean Water Act in terms of, we used to have rivers catching on fire in this country, and we don't anymore. And that was more of an oil issue than a nitrogen and phosphorus issue. But, we're making a lot of progress, and we can make progress. I do want to say that we don't have a perfect solution for nitrogen and phosphorus, right? We could only feed about half the people on Earth without using nitrogen fertilizer. And we take a huge amount of nitrogen. We use a lot of fossil fuels to make nitrogen fertilizer. We spread it all. And you mentioned in the intro a lot of the impacts. We can't do without it. And so we need to use it more efficiently. And where we can't use it efficiently, we need to catch it before we release it into the environment. And that's sort of the game. But It's a game that is doable. It just requires wise management as opposed to management by neglect.
One of the great things we could do is have less animal agriculture, which uses most of our farmland to grow those crops for animals, and then you lose a lot of those nutrients in that transition between, 10 times waste for a protein that and not to mention that the manure pits and so forth from animals are way more than humans are producing, and there isn't a sewer system usually in place for that.
So you're 100% right. Meat consumption is a big issue both on the carbon footprint side and on the nitrogen and phosphorus footprint side. If you're looking for one dietary change that you're going to make to help all of the environmental issues we've talked about today, it would be a reduction in beef consumption, in particular beef and lamb consumption, and dairy. I will just I'll put some numbers to what you said, Dale, just as a point that supports what you're saying, but it's a bit of a yes and. So imagine that you dump 100 units of nitrogen on the farm field, and you transfer that all the way down to a human mouth in New York City. You would lose about 96% of that if that nitrogen was in beef patty. So if you start with a farmland, you feed the corn to the cow, you make the cow into a beef patty, you put it in a human mouth. By the time a human mouth gets that, there's only 4 units of nitrogen left. 96% loss. But if you did it with wheat or corn or whatever directly, you'd still lose about 83%. So it is definitely important, and cows are very nitrogen intensive, but in terms of leakage to the environment, you lose a lot no matter what you do. And that's a lot about the way we farm. And this is not talking about what happens downstream from us in terms of sewage treatment, but you lose a lot just in the application of the fertilizer, how it's put on, when it's put on. Those things require better farm management. And so, yes, for sure, less red meat is really, really important. And yes, also, we need to do a better job of managing our farms.
Well, this has been a really great conversation. I appreciate both of your inputs. I hope that the Clean Water and the Clean Air Act stay strong, even in the present environment. And we're all on edge all the time with the environment and the current United States government. But there's another issue. Thank you very much. I really appreciate your coming to On Facing Future today.
Thank you so much for having us.